Find the general solution to the ODE. So our ODE here is y prime plus 2y equals 0. So the first thing that anyone ever tries, including me, is what if we just try integrating the whole thing? All right, so what if I do integral of y prime dx? I'm going to split it between the two terms, so then plus integral of 2y dx equals integral of 0 dx. And that's not so bad. So the integral of the y prime dx, well, the integral and the derivative essentially cancel, so we end up with y. But we're still left with here, I'm going to bring the 2 out. So we've got 2 integral y dx equals, let me just clean up that dx. Dx equals, the integral of 0 is a constant of integration. So that ends up just being our c. So this got a little closer here. We got rid of the y prime term, and this part's gone, but now we're stuck with the integral of y dx. The problem is, we don't know what y is, so we don't know what the integral of y is. So all we've really accomplished is we've taken a differential equation we don't know how to solve and traded it for a worse looking equation we don't know how to solve. So that's not going to work. All right, well, what if we try something else? And here we're going to try an integrating factor, and I'm just going to pull this out of thin here. Error here, we're going to try mu of x integrating factor equals e to the 2x. All right, so now what if we multiply the entire equation, differential equation, by e to the 2x? So if we do that, we have e to the 2x times y prime plus then the 2y, we get 2. I'm going to put e to the 2x in the middle, times y equals, over here we have 0 times e to the 2x, which is still just 0. All right, so now we have this bit, and if we just try integrating again, it doesn't look like anything will happen, but there's this very nice thing we can do with this. So we're essentially going to do the reverse product, a reverse product rule. So let's see how that's going to work out. So now I'm going to go over here. What if I took e to the 2x times y, and I took the derivative of that whole thing? Right? Well, if I do that, then we end up with the derivative. I'm going to do the non-derivative of the first term times the derivative of the second term, which is just y prime, plus I'm going to do the derivative of the first term, prime, times the non-derivative of the second term, y. All right, so if we keep going here, I can pretty much drop those parentheses and end up with e to the 2x times y prime plus, over here I have to take the derivative of e to the 2x. Well, that's a chain rule. So the e to the 2x, when you take the derivative, sticks around. So I have e to the 2x. But right, the exponent is going to drop down in front, and we're going to have that prime. And then the y is still sticking around. We didn't do anything to that y. All right, so then writing again, this part's done. So I'm just going to rewrite it, e to the 2x, y prime, plus the derivative of 2x is just 2. Right, the x turns into a 1. So we end up with 2 e to the 2x times y. Then if you look, this e to the 2x y prime plus 2 e to the 2xy is exactly what we have over here. E to the 2xy prime plus 2 e to the 2xy. And so what we can do is we can essentially use the product rule in reverse and go from here to here. And so on this equation, we can end up exchanging this with e to the 2x y, the whole thing prime, equals 0. Now if we try and integrate, instead of getting integral of y, which you don't know of, we're actually going to have an integral cancel. So right, take this equation, we're going to do integral of e to the 2x times y, the whole thing prime, dx, equals integral of 0 dx. So now on this side, we're just going to have it cancel, right? The integral and the derivative basically cancel with each other. So we're just going to end up with e to the 2x times y equals, the integral of 0 is constant of integration. And so then the solution, we have e to the 2x times y equals c. If I want to solve for y of x, I'm going to multiply both sides by e to the negative 2x, or equivalently divide by e to the positive 2x. We'll end up with constant integration, e to the negative 2x. And this is actually the solution to that differential equation that we started with.